Conversions of roots of negative numbers from single form to basic form. This in high school is part of the American curriculum. So let's say, for example, you have square root of minus 2. This is sorts in single form, and we can change it from single form to basic form. In this case, we can break the square root of minus 2 into square root of minus 1 times 2. Minus 1 in this case could be referred to as negative perfect square. And we can break this into square root of minus 1 times square root of 2. Square root of 2 is a full imperfect square. There's no perfect square greater than 1 in it. And if you find the square root, you get a decimal. But square root of minus 1 is I. That's I standing for imaginary number. Because in math, it's believed that minus 1 is also I square, or I times I. Therefore, square root of minus 1 is also square root of I times I. To better understand it, it's like square root of 4 is square root of 2 times 2. And since you have the same values multiplying themselves, under square root, you pick one of them, that's 2. And in this case, square root of I times I is I. So we have the square root of minus 1 as I. Now we know the square root of minus 1 is I times square root of 2. I times square root of 2 is I root 2. And this is our final answer. Therefore, square root of minus 2 is I root 2. That's converting it from single form to its basic form. We can also convert it back to this. But let us take another question. Let's say square root of minus 4. Under the Nigerian curriculum, at the high school level or secondary school level, the square root of minus 4 is impossible. You don't touch it. But as you go higher into your A levels or in 100 level in an higher institution, the square root of minus 4 can be found. You can break down square root of minus 4 into square root of minus 1 times 4. Since the square root of minus 1 can be found, you take out the minus 1, leaving the plus 4 behind. Because when you multiply minus 1 times 4 or plus 4, you get minus 4. The reason why you are bringing out the minus 1 is just to make the 4 positive. Next, you give them their separate square roots. Square root of minus 1 times square root of 4. Square root of minus 1 is imaginary number I times square root of 4 is 2. You multiply them together. I times 2 is 2I. So the answer to square root of minus 4 is 2I, where I stands for imaginary number, which is the square root of minus 1. Let us take another question. Let's take square root of minus 8. Square root of minus 8 can be square root of minus 1. Ignoring the minus, in 8, you have 4 as a perfect square greater than 1 in 8. Let's just put 8 here. Then on the next line, we're still going to break down this 8. That you have square root of minus 1. The perfect square greater than 1 in 8 is 4 times 4. Then 4 times what to give us 8? 4 times 2. So first, because of the minus with the 8, you brought out minus 1. So you can have 8 on one side. Then you broke down the 8 into a perfect square, which is 4. And another number that can multiply to give you 8, which is 2. You give them a separate square root. You have square root of minus 1 times square root of 4 times square root of 2. Square root of minus 1 is I. Square root of 4 is 2. And square root of root 2 gives a decimal, so you leave that as root 2. So you have times root 2. So you multiply the 2 times the I, you have 2I, then times root 2. So you have that as 2I root 2. The answer to this question is 2I root 2. Or you can say 2 root 2I. Basic to single form conversions. Next is converting it back. From what we just solved, we took square root of minus 2 to I root 2. Let's say we have it as I root 2. We want to convert it back into root 2. That's from its basic form back to its single form. We have to get this I back in square root. And if we are getting it back in square root, this I is linked to this root 2 by times. You separate them first. Then this I will bring it back in square root. What will give us I in square root is I times I. You multiply it by itself to bring it back under square root. Then you still have times root 2. This times root 2. I times I is minus 1. So you have the square root of minus 1 times square root of 2. At this point, since they are linked by times, we can group them together. We have square root of minus 1 times 2. Square root of minus 1 times 2 is square root of minus times plus is minus. 1 times 2 is 2. So we have it as square root of minus 2. We've therefore converted it from its basic form, which is I root 2, back to its single form, which is square root of minus 2. Remember, we converted the square root of minus 8 to 2i root 2 or 2 root 2i. Now we want to convert 2 root 2i or 2i root 2 back to square root of minus 8 or root minus 8. They are all linked by times. You can break this down into 2 times root 2 times I. So we have it as 2 times root 2 times I. We need to put this 2 back under square root and also this I back under square root. So we have it square root, that's 2 times 2, because square root of 2 times 2 will give you 2, times root 2. Since this 2 is under root, or you still have root 2 here, you leave it as root 2. Then times square root of this I, we need to bring it back into square root or into root. You have it as I times I. On the next line we can have square root of 2 times 2, that's 4, times root 2 times square root of I times I, that's minus 1. Each of them are all under square root. Next is we introduce one full square root, and since they are linked by times, we multiply them under the square root. 4 times 2 times minus 1. This equals 4 times 2 first, that's 8. 8 times minus 1. 8 times minus 1 is minus 8. So we have our answer as root minus 8 or square root of minus 8. That means we've been able to convert 2 root 2i from its basic form back to its single form, which is root minus 8.